So what you just read about was the type of eruptions that can occur with different types of volcanoes. The type of eruptions is connected to the type of magma that volcano produces that we learned about yesterday. Let's go ahead and take that information and put it into our notebooks. Here's my notebook page that I'm going to be writing on. You can see that it's turned sideways, so landscape, but you can do yours however you like. We're going to start with the title, top center, and these are going to be like bubble style notes. So our title would make sense to be eruptions. There are two main types of eruptions that you can get with different volcanoes. One of those types is called non-pyroclastic. Non-pyroclastic eruptions are, first of all, non-explosive. If you think about the word non-pyroclastic, that kind of makes sense that would be non-explosive. We typically associate that prefix, pyro, with somebody who likes to deal with explosions and fire. So non-pyro, okay, that means non-explosive. If the eruption is non-explosive, what you would see is that the lava flows out quietly. You can still get kind of like lava fountains where it shoots up a little bit from the volcano, but it's not going to be an explosive, catastrophic eruption. When you have a non-pyroclastic eruption, people have time to evacuate. They would know 2 or 3 days ahead of time maybe that the lava was heading a certain direction. So it's not like an instantaneous death kind of eruption. Non-pyroclastic eruptions occur when you have primarily basaltic magma. We learned about the types of magma yesterday. Basaltic magma is often made from oceanic crust because most of ocean crust is made of the rock named basalt. And basaltic magma has a low amount of trapped gases. It has a low amount of trapped gases because it has a low silica content. Silica is a mineral, it's kind of like sand. It makes lava more sticky. So if there's not very much of it, the lava is not very sticky. The gases are just free to kind of bubble to the top and escape. And so that means that there's no pressure buildup. And if there's no pressure building up, then the lava is just going to flow out quietly. It's not going to be an explosive eruption. These types of volcanoes, these types of non-pyroclastic eruptions from volcanoes, tend to happen a little bit more continuously. So we'll put that here, erupt more continuously. It's not like a once-in-a-lifetime event. It tends to just kind of keep going. Such as Kilauea in Hawaii. Kilauea has been erupting continuously since the early 1980s. That's it for the non-pyroclastic side. Now let's move the notebook over and learn about the pyroclastic eruptions. So back to the top, and we're going to the other side. The other type of eruptions are pyroclastic. Again, the first part of that word pyro we typically associate with somebody who likes explosions and fire, so it makes sense then that this is the explosive kind of eruption, so we'll put that over here. The second part of that word actually means rock pieces. Clastic means rock pieces. So we are exploding pieces of magma or pieces of rock out of the volcano. Pyroclastic eruptions typically happen with rhyolitic magma. Rhyolite is a light-colored rock that's usually found in continental crust. So explosive eruptions tend to happen more with continental volcanoes, whereas basaltic explosions tend to happen more with ocean-based volcanoes. Rhyolitic magma has a high silica content, and so that means it can trap gases and build up pressure. It's very sticky, and so the gas bubbles just get stuck in the magma and they can't go to the surface and break. So there's a high amount of trapped gases. And that builds pressure. Once that pressure builds up to a breaking point, then you're going to get that pyroclastic eruption. So, what do you get with a pyroclastic eruption? What comes out of the volcano? Typically, with a pyroclastic eruption, you get what's known as a pyroclastic flow. So what is that? Well, again, if you think about what the words mean, pyro means explosive, clastic means rock pieces. So the explosive side of that, you get lots of hot, often poisonous gases. And you also get rock pieces that are known as tephra. All of the rock pieces together are known as tephra, but we can categorize them according to their size. So let's do that down here underneath. And I'm going to add one more color to this just to kind of emphasize that we've got some new vocabulary here. So tephra is categorized mostly by size. So we have two words for the largest pieces of tephra. Bombs start out as a liquid, so it's liquid magma that hardens as it falls. And they are very large, or comparatively large. They are greater than 64 millimeters in diameter. That's over half a meter. If you wanted to put that in English units, that would definitely be over half a yard. So if you had a piece of magma that was hardening as it was falling, that was over half a yard big, that would be a bomb. That's a pretty big piece to be ejected from a volcano. Also on the large end, we have blocks. Blocks are the same size, but they're already solid when they come out. So again, they're large. And that means greater than 64 millimeters. So these would be like boulders getting thrown out of a volcano. Those are pretty big pieces. Then we have, kind of snake this one down underneath here. The next smallest size is called lapilli. Lapilli are more like pebble size. And they are between 2 and 64 millimeters. So less than half a yard. And then the smallest of the rock pieces, so the smallest of the tephra, is ash. And ash is less than 2 millimeters in diameter. And of course, everybody's got experience with ash and what a fine kind of powder it can be. Let's do one more thing here before we finish up, and let's put an example of a volcano that has pyroclastic eruptions. Pyroclastic eruptions can be from cinder cones. They can also be from composite cones. Composite cones, of course, vary back and forth between the two, but one of the most pyroclastic eruptions, or most famous pyroclastic eruptions, was Mount Vesuvius in Italy. And then another one that's pretty famous is the eruption of Mount St. Helens in Washington. Both of those were pyroclastic eruptions. The pyroclastic flow travels so quickly, you can't outrun it, you can't outdrive it. It's just, it's super fast coming down the side of the volcano, and super destructive as well. All right, so make sure that you've got all the notes in your packet. If you need to go back and rewatch the video again, you could certainly do that. And that is it for today.